let's draw a line such that the ratio of the length of the line to this longer section of the line is equal to the ratio of the longer section of the line to the shorter section of the line. So let's give them variables. Let's call this A, the short section, and B for the long section. So the entire length of the line, A plus B, the ratio of that to B, or the longer section of the line, is equal to the longer section of the line, B, over the shorter section, A. So let's give this ratio a special name. Let's say B over A equals, I don't know, Greek letter, phi. And this ratio has to be greater than 1 because it's a ratio between something that's bigger over something that's smaller. So phi is greater than or equal to 1. So we can replace this with phi, A plus B over B equals phi. But wait, can't we just write this as A over B plus B over B? And A over B is just the reciprocal of B over A, right? So that's just 1 over phi. And B over B is just 1 equals phi. So if we try solving for this, multiply both sides by phi, you get 1 plus phi equals phi squared. And if you rearrange that, you get, and if you use the quadratic equation, right, negative b plus or minus the square root of b squared minus 4ac all over 2a, you get phi equals negative b value is negative 1. So negative 1 is positive 1, plus or minus the square root of negative 1 squared is 1, minus 4 times, that's an A, 4 times 1 times negative 1, so minus 4 times negative 1 is minus negative 4, which is just positive 4, 1 plus, 4, all over 2 times 1. So 1 plus or minus root 5 over 2. Now if we have 1 minus root 5 over 2, that's not going to be greater than or equal to 1 as stated in our restriction up here, right? So your final answer is 1 plus root 5 all over 2. 5. Wait, that's not nice. 1 plus root 5 over 2, which is approximately, let's check, 1 plus root 5 over 2, 1.618. 1.618. Yeah. So this is called the golden ratio, and it appears a lot in nature. And this is just a short derivation of it. Thanks for listening.